Hi class, this is our Monday night homework. I hope you like the new program that I'm trying out today. Today in class we talked about a topic called slope. And slope tells us the steepness of a line. And we had two different equations we talked about. One was change in y over change in x. And the other one was rise over run. And we do want to remember sometimes rise is actually drop. And when rise is drop, our slope is negative, so it's going down. The one that most of us, I'm sure, like a little bit better is the rise over run. It's a little easier to remember. So we'll use that one today in our homework. For our first example, they actually give you the two dots to use. So they give us this point here and the second point. If they don't give you points, remember we want to find perfect intersections so we know the value. If I choose this point right here, I don't actually know the value because it's in between two of the lines. So make sure that we do choose perfect intersections, which very nicely they gave us for this problem. Just like we read from left to right, that's how we're going to look at our graph. So we're going to go across our graph, and first we hit this point. So that's where I start, and I need to get to my second point down here. So first we're going to rise or drop. For this problem, there's no way I can get to my second point if I go up from my first point. It's not going to help me get there. So I know that I have to drop, and drop means we're going to have a negative number. So I'm going to go ahead and write my negative, and let's see how much I need to drop to get there. So I'm going to go down 1, 2, 3, 4, 5. So I go down 5, and then I need to run, and I'm going to run 1, 2, 3. So I dropped 5, ran 3. So our slope, and remember slope is m equals negative 5 thirds. And that's all we're doing for right now. Let's look at a second example. Okay, example 2. Again, we're going to go from left to right, so let's look at the points they gave us. We have one here, one here. To go from these 2 points, I am going to rise, so I know it'll be positive. I'm going to go up 1, 2, so I rose 2, and then I run 1. We can simplify this. 2 over 1 is just simply 2. So we can say that m, our slope, is 2. You can keep the positive in there if you would like, if that helps. So again, positive slopes are going to be going up the lines, and negative slopes, like our first example, the line is going to be going down. Okay, let's do our last example here. On this one, I want us to pay close attention to our values on our x and y axis. They're not 1. So we need to make sure they go up by tens, that when we count rise over run, instead of counting 1, 2, 3, we're going to count 10, 20, 30. And we need to find some perfect intersections here. So I'm going to go ahead and look through the graph. This first point, that is not a perfect intersection, so we don't want to use that. But this next point is. So right here, that's a perfect intersection. So that's where I'll start. And let's go find another one right here. And I can find a third to double check my work. So I'm going to use these 3 points. And we're going to think of rise over run. To get from the first point to the second, I'm going to rise 1, run 1, 2. Rise 1, run 2. So I think that my slope is 1/2, and I can go ahead and double check that. So to get from the second point to the third point, I should also be able to rise 1, run 2. That seems to work, and we can keep going. Rise 1, run 2. There's a perfect intersection. Rise 1, run 2. Another one. So that can definitely help us double check, just make sure we did our work correct. And again, this is a positive slope because our line is moving upwards. That is all for our notes for today. You can go ahead and do on your own problems, and Mr. Lopez will be there to check for you tomorrow. Please email if you have any questions at any point throughout the week, since I'm not going to be here. Have a good week.